This video, we're going to look at the SI units of the quantity of volume. Okay, now when we typically talk about volume, we are talking about the 3D space. We're talking about the amount of space an object takes up in 3 dimensions. So here is an axis shown in X and Y. This is in 2 dimensions. And we know that, well, if we're talking about volume, we're talking about a 3D shape. So we're actually talking about a 3rd dimension as well. Now you'll have done this in maths where you know that this is called the y-axis, this is called the x-axis, and this is called the z-axis. Now, if you think about it, how this is actually made up, this here, if we were talking about a cube, we would be shaped here. It's 3 dimensions, and you can start to see how the x here is our cube, and we can see how we've got volume. And when calculating volume, we do length times width times height, which is the same as thinking about these 3 axes. So we might say that x is length, we might say that z is width, and we might say that y is the height of the cube, if you were thinking about it like that. So when we're talking about volume, that's what we're talking about, length, width, height. Now, the SI unit, or the standard unit for volume, is what we call the meter cubed, okay, called meter cubed, which is essentially, if we take this cube here, and we say, okay, well, if we go a meter in each direction, so if we say that the length, the width, and the height are each 1 meter, then we would have an SI unit of 1 meter times 1 meter times 1 meter, length by width by height. Now, 1 times 1 times 1 is just 1. But meters times meters times meters is meters cubed. So 1 meter cubed, or we usually measure our SI units in meters. Now, if we were to try and think about, well, what's the relationship between meters cubed to centimeters cubed? Some people think, oh, it's 100. Well, there's 100 centimeters in a meter, so it must be 100 centimeters cubed is equal to a meter cubed. Some people think that this is true. Now, I understand why you think that, because 1 meter is equal to 100 centimeters. You're right about that, okay? For every 1 meter, there are 100 centimeters. You have to remember that this is cubed. So if we think about it, we go back over here, we'd say, okay, well, if this is a meter, then that's 100 centimeters here. And if this is a meter, then that's 100 centimeters there. And if this is a meter, then that's 100 centimeters there. So what we actually get is that 1 meter cubed is 100 centimeters times by 100 centimeters times by 100 centimeters. So that will give us 100 times 100 times 100. And that's going to give you 1 million. So 1 million cm cubed, or we see this written as 1 by 10 to the power of 6 centimeters cubed. So this is a common mistake people make, that they think 1 meter cubed is equal to 100 centimeters cubed. That's not actually true. That's incorrect. What's actually true is that 1 meter cubed is equal, or for every 1 meter cubed, there are 1 by 10 to the power of 6 centimeters cubed. Or another way of saying this is, for every 1, there is 1 meter cubed. So there's the relationship between meters cubed and centimeters cubed. I want to show you another thing as well. Sometimes when we talk, when we measure volume, people talk about liters. So liters is a measure usually when we're talking about liquid volumes. Now, liter is a nickname for a different amount. Instead of meter cubed, I'm going to change this over here. You see this here, 1 dm. Now, dm stands for deci, meaning to. So 1/10 of a meter, or 1 decimeter, is the same as 10 centimeters. So 1 decimeter is 10 centimeters. So 1/10 of a meter, 10 centimeters. Now, if we have 1 decimeter this way and 1 decimeter this way, then we're doing 10 centimeters and 10 centimeters. Over here, what we'll end up getting is that decimeter times 1 dm cubed, like that, because we're 3 times 1 is 1, so 1 by 1 by 1 is 1, but decimeters by decimeters by decimeters is decimeter cubed. And that's the same as saying 10 centimeters times 10 centimeters is equal to 10 by 10 by 10 is going to give you 1,000, and that's cm cubed. So these two things are the same thing. 1 decimeter cubed is equal to 1000 dm cubed. Sorry, 1000 cm cubed, apologies. Now, a nickname for either of these things is a liter. So a liter is 1000 centimeters cubed or a decimeter cubed, all right? So this 1 dm cubed, there are 1000 for every 1000 dm cubed. Or 1 liter for every 1000 cm cubed. Okay, so liter, it can be used interchangeably with these things. So 1000 cm cubed for a liter or 1 decimeter cubed for a liter. All right, guys, so they are the two relationships that we need to know before we can do some questions. The first one is this, okay, is this relationship here. So it's probably worth noting that down. SI unit for volume, relationship here between centimeters cubed and meters cubed. This is our relationship between centimeters cubed and decimeters cubed. Okay, so once we know that, then we're ready to do some problems with that, okay? Now, just before we do, I'm going to show you this over here, and that is that 1 meter cubed here is equal to 1000 liters, or 1 by 10 to the 6 centimeters cubed, and that is what we call measured at standard temperature and pressure. We're ready to do some prep for you, and then you're going to do one yourselves. So let's say you are asked to convert the following to SI meter cubed. So let's take 74 cm cubed. And that's currently not in SI units. We need to convert to meters cubed. So we're going to use a unit analysis again there. So where I set up my fraction that relates centimeters cubed to my SI units meters cubed. Now I am going to set up using units first, just writing down the units on this fraction. I want centimeters cubed to be on the bottom so that it can cancel out with what I'm starting with. And I want meters cubed to be there so that I can have my final answer in meters cubed. There's no other unit left, only meters cubed. So that tells me I'm right. The next thing is, what's the numerical relationship between meters cubed and centimeters cubed? For every 1 meter cubed, I know that there is 1 by 10 to the power of 6 centimeters cubed. Now I've got a sum to do. I'm going to do 74 times by, and I'm going to open my fraction button, and I'm going to do 1 in the top box, and I'm going to do 1 by 10 to the power of 6 in the bottom box. I'm going to go ahead and do this now. 74 times by 1 by 10 to the power of 6. And what you should have got is 7.4 times 10 to the negative 5 meters cubed. So that's your final answer in meters cubed. Okay. All right. So I'm going to get you to do one now. You do this one. Okay. You do this one. We'll say 143 centimeters cubed. Pause the video and do that now. Okay. So if you needed some help with that, I'm going to get you to set up the fraction. So pause the video and decide which unit needs to be on top, which unit needs to be on bottom. Okay, so what you should have done is put centimeters cubed on the bottom so that it can cancel with those centimeters cubed, and you should have put meters cubed on the top so that we're left with meters cubed. So our answer is in meters cubed. That's how we know it's right. Now pause the video and write down the numerical relationship between meters cubed and centimeters cubed. Okay, so what you should have done here is put 1 meter cubed, and for every 1 meter cubed, there is a big number of centimeters cubed. It's 1 by 10 to the 6 centimeters cubed. Okay, so I'm going to go ahead and we are going to put that in our calculator and see what you got. Right, so what you should have got here is 1.43 times 10 to the negative 4. If you got that, well done. Okay, all right, I want to show you another problem where we can make this a little bit more complicated. What if you were given something like this? You were given 24, no, we won't say 24, we'll say 29 decimeters cubed. Well, I've told you how you can go from decimeters cubed to centimeters, but I haven't told you how you can go from decimeters cubed to meters. So the best way to do this is go from decimeters cubed to centimeters cubed, and then go from centimeters cubed to meters cubed. Okay, so the way I would do this is take my decimeters cubed and I would convert to centimeters cubed, because I know that relationship. So I want to get rid of decimeters cubed, so I'm going to put that on the bottom here, like that, and they cancel out like that. And I'm going to put cm cubed on top. Then I'm going to multiply it by a second fraction, where I put cm cubed on the bottom, and I put meters cubed on the top. And then these cancel out like that, and I'm left with meters cubed, which is what I wanted to have in the answer. So my answer is going to be in meters cubed. Now note how I never write units first. That's really important. And if you learn to do that, your maths is going to get so much better, and it's very hard to ever get one of these wrong. All right, so let's look at the relationship. How many centimeters cubed is there in a decimeter cubed? Well, we learned earlier that for every 1 decimeter, there are 1,000 centimeters cubed in that. Okay, so there are 1,000 centimeters cubed in a decimeter. And then for every 1 meter cubed here, there are 1 by 10 to the 6 centimeters cubed. So now I'm going to have to put all this into my calculator. I'm going to do 29 times by 1,000 over 1. And then times all of that by 1. So fraction again, 1 over 1 times 10 to the 6. 10 to the 6. Put that in, and the answer I'm getting here is I'm getting 0.029 meters cubed. If you got that, well done. And now you guys should be ready to have a go at some practice problems. So let's have a look here at these ones. So we're doing, I'm going to rub this one out actually. Shouldn't be there. We're going to do 108 to 111. Pause the video and do them now. All right, well done. If you manage to do them, you're confident about your answers, we'll go through them the next day in class. Here we see something in red, which means that we're going to take this down in our definitions dictionary. So the standard conditions of STP, this is the accepted values across the world, is that we use 100,000 pascals of pressure. This is standard pressure, or this is a pressure, what we call atmospheric pressure. So this is the normal pressure of the atmosphere. So nothing added, nothing taken away. It's what we call atmospheric pressure. So in our room, in our lab today, or in our home, it's probably very close to this number is our standard pressure. This is just what the atmosphere puts on us. If we increase the pressure, then it will go up. If we somehow decrease the pressure, then it will go down. And then this here is 0 degrees Celsius, or 273 Kelvin is our standard temperature. So it's something that we need to be aware of. So writing that down. Okay, we're on to some mixed practice now. So what you have to do is convert the following to standard units. So pause in the video and have a go at converting all these. Pause the video, do that now. Okay, a reminder, if you haven't done these, this should go to meters cubed, so centimeters cubed to meters cubed. This needs to go to pascals, so these are all mixed up, and you need to try and do these from memory without looking back at what you did. At this stage, you should be able to have a go at these from memory. So pause the video and have a go at them. All right, guys, that's that mixed practice set, and we shall see you in the next lesson.